Hello and welcome to SDN Tech Forum. In last video, we built Meraki network. In this video, we are going to take a step further and use Cisco ISE to deploy adaptive policy for consistent authentication, authorization, and policy rollout. Cisco ISE is very popular with Catalyst environment, like you have seen in SDA playlist. We are using ISE heavily to control all kind of policies, and now we will use the same ISE within our Meraki network to have a consistent policies end to end. Isn't it exciting? All right, let's quickly look at our test bed. Let me zoom it. We have a Meraki dashboard because for Meraki network, you are going to configure everything at Meraki dashboard in cloud. And then we have ISE. We are going to create a Meraki dashboard and ISE integration. From there on, this is my Meraki network, one of Meraki network where I'm using MX68. And what I have brought new is MS390. We are bringing a switch so that we can connect our users and do segmentation, micro segmentation between the users. Here, as you can see, we are doing .1x for employee and MAB authentication for our IoT devices, and we are making sure that employee can talk to IoT only with certain access contract or maybe certain ports and protocols. This is just a use case. So this employee can be an IoT developer which need access, versus you may have an employee who's finance and HR and they have no business talking to IoT. So how you can control that, all this policy enforcement, how it happen using adaptive policy, and where you define your policies within ISE, we will see in this video. All right, so this is the agenda. Now let me walk you through the high level of the steps what we are going to perform to achieve this goal. First thing, ISE and Meraki dashboard integration. Then we are going to enable adaptive policy within the network where we have configured a new switch and our end host is connected, all those things. Then we will start creating Meraki network or configuring Meraki network. We will configure global access policy, we will configure radius server, we will assign authentication on switch ports, and we will also create group policies at Meraki side so that it matches the filter list or ACL that is coming from ISE authorization profile. And you will see when we start doing things. You also have to make sure that Meraki switch is available in ISE so that it can accept radius request. Create a Meraki authorization policies because ISE is your single source of truth for authentication, authorization, and policies. So you need to create policies for your Meraki world. And then finally, we will connect a couple of hosts, verify they are authenticating, getting onboarded, IP address, etc. from ISE. And we will also do some kind of test to make sure that policies are working as expected. So this is the goal or agenda for this video. Before we get started, let's look at some of the prerequisite or the quick read what you should do. So the first link I want to highlight is MS Switch Access Policy .802.1x technology, and I have done 3 or 4 very detailed video around this technology, so you can go back to SDN Tech Forum and search for 802.1x. Here you will see we are talking very much in detail at the packet level about this technology, how supplicant talk to authenticator and get authenticated, policies are enforcing all those things. So this is about the technology without any vendor. This is kind of like a vendor agnostic discussion. But coming back to Meraki world, MS Switch access policies for 802.1x, give it a read. It essentially is telling you that now you have a capability to define radius server at org level. That means you do not have to create radius server per network, but you can use or create one radius server at org level and call it within different network. This is essentially what we are going to do. Then this is the most important part, host mode. You need to be aware there are 4 authentication host mode. Single host, This is the default. That means you want to connect a host and make sure that it is a legitimate host. It can prove that it is who it is claiming, and then you get right policies and authorization. Then you have the multi-domain. Like if you have IP phone and a PC connected, then probably you need a multi-domain authentication for voice and data VLAN. Then you can have multi-auth and multi-host as well. Access policy type. In Meraki, you have three type of access policy: 802.1x, which is default. Then you have a MAC authentication bypass. That means the devices like your IoT devices, printer, other equipments who are not CPU or resource intensive, that means they cannot support a supplicant agent. Then what you can do, you can simply trust them based on the MAC address, their MAC address. That is the MAC authentication bypass. And then there is a hybrid mode, which is actually a combination of two. That means you can enable hybrid mode and it will support .1x and Mac at the same time. So you have this freedom to connect whatever you want to connect. And there is also one interesting thing is you can speed up. By default, it will first do .1x, and once .1x fails, then it fall back to mab. But now there is a knob where you can say speed up this thing and it can do .1x and mab in parallel. So the onboarding is pretty fast. Increase access speed. This is essentially what I'm talking. Then you have the change of authorization, which is ISE capability. That means upon first authentication, ISE can do COA, and it can do authorize. It can apply dynamic VLAN, ACLs, etc. based on the authorization profile. Other radius features, especially from Meraki side, we have radius accounting, we have radius testing. That means Meraki switches will periodically send access requests to radius server using identity Meraki.802.1x test. So it will test the Meraki reachability and liveliness because it's a critical infra. And then we have radius monitoring also. If all radius servers are unreachable, you can define up to 3 radius server at org level, and if all radius servers are unreachable, client attempting to authenticate will be put into a guest or critical auth VLAN depending on which is defined. So that means if in case you have a radius outage, a client can still connect and perform some basic actions. Dynamic VLAN assignment and etc. They are typical from ISE side. So if you are not aware of ISE concept, authorization, authentication, I highly recommend you go and watch ISE authorization policy as I'm showing here. Here I'm walking you through how to create authorization policy, authentication policy, and authorization policy for radius authentication. And there are a couple of other ISE videos are available here. All right, let's go back to our workflow. So first step, ISE and Meraki dashboard integration. For that, what do you have to do? You have to come to ISE Work Center and then go to integrations. Within integration, you'll see two options as of today: ACI, which is for data center, and then we have Meraki. If you click on Meraki overview, it talks about the advantage what you can get or this solution, what happened when you have Meraki to ISE integration. It is a literature, so go ahead and read. Then we have connection. Then we have connection. Here essentially you are doing the integration. We already have one org integrated, but in case you want to create a new integration, click on add connection, give it a name, and then use Meraki dashboard API, hostname and API key. If you are not sure how to find this, go back to your Meraki org, click on API and webhook, and here you can find that information. This is how you create the integration. And what is the result of this integration? Once your integration is created, you can go to sync state, and as you can see, we have certain policies, ACL and SGTs all are getting fully sync for this one particular organization, and it syncs every 5 minutes. If you have made any changes and you want to sync it now, immediately you can do sync now. So these are the policies, ACL and SGTs we are syncing. All right. As you can see, employee has SGT 4 and IoT has SGT number 5. Let's go to sync selection. Why it is important? So whenever you are making an integration, it's not that ICE is sending a blind copy or a dump to Meraki. No, it's not like that, because within ICE you may have a lot of things. So what you can do, or what you have to do, is you have to come to sync selection and choose whatever things you want to sync or send to Meraki dashboard. So here, as you can see, I have 5 of 5 egress policies selected. However, for ACL, I have 5 ACLs, but I'm only sending or syncing 2 of them. Same with SGTs. I have 19 SGTs, but I choose to send only 8 of them. Why is this critical? Because there are certain limit. At this time, you can select up to 60 SGTs to sync. So in case it's a massive environment and you have more than 60 SGTs, if you sync it all, then you may lose something critical or what you need for your policy. So sync what you need. All right. So this is all about integration. We have completed step 1. Now let's go to step 2, which is pretty straightforward. That means you have to enable adaptive policy support or .1x support for your network. And for that, we are going to go to organization, adaptive policy, find our network, find our network, and make sure we have adaptive policy enabled. Or if it is not, you can click it. But as you can see, we have adaptive policy already enabled. So that's step 2. Create a global access policy on MS390. So now we are going to create a radius server for our network, but we do not want to configure individual radius server per network. So what you can do, you can go to org settings and create a radius server at the org level. And here, as you can see, I have created a radius server at org level, MCS ISE, and this is my server IP address, and etc. etc. So that when I go to switch and I'm ready to create access policy, you can see I have my radius server available in dropdown. I already have it available in my dropdown. That's what I'm using, right? So let's say you want to add a new radius server, come here and say add access policy, and this open up a new uh, page. Here, as you can see, we have select radius. You can select the org level radius server. Then you can define the host mode, what we discussed earlier, single host, multi-domain, multi-auth, all those things, and access policy type. Do you want .1x? Do you want MAC authentication? Or you want hybrid? Let's say hybrid, and we will check this box, increase access speed. The very important thing is .1x control direction. And here you have two options, control direction both and inbound only. Let's understand what are these options. Set to inbound only to allow traffic to egress unauthorized switch port. That means when switch port is not or authenticated, you allow egress traffic like CDP, LLDP, EPOL, all those traffic will be allowed, but ingress traffic is restricted. However, if you select default, both egress and ingress traffics are restricted. So make sure you select inbound only so that your initial EPOL and CDP, LLDP for profiling is available. Then you can do other things like what is the failover authentication VLAN, what is your critical auth VLAN looks like, what will be the re-authentication interval, what is your voice VLAN. On all those things you can configure and mention here. All right, so we have it already configured. We have done minimal configuration, that means host mode, single host, hybrid authentication, and we are speeding up this access speed, and also control direction is inbound only. radius attribute specifying group policy name, we are using filter ID. So attribute what we accept from ISE is filter ID, and we will talk about that in a moment. So this is how you create your access policy. Uh, First you create your radius server at org level, and then come here and create an access policy. Because once you create the access policy, you can start configuring or assigning this access policy to your switch port. Yes, we do not want to make any changes, so let's leave. Now here, as you can see from the test bed, let me go back. We have port 24 and port 21, which is configured for .1x and MAB authentication. So to configure that or configure any ports, what you have to do, you have to go to switch ports, find that port, and then you can say, you can name it. This is optional, and then you can say access policy, the newly created radius policy, which is radius auth. And then you can put that in VLAN, whatever VLAN you want, because if you are doing authorization profiling and dynamic VLAN assignment, upon authentication, it will be upon authentication and authorization, the switch port will be configured automatically for that VLAN. Rest of the things are okay. So this is how you configure your switch port for radius access. All right, let's go back to our workflow. So we have created a global access policy. We have assigned switch ports for .1x and MAB authentication. Now, create group policy equivalent to filter list, matching with ISE authorization policy. So let's spend some time in ISE first. So within ISE, component, network devices, you want to make sure that your ISE, your switch, Meraki switch is available within ISE as NAD. And this is my switch. I have created a static entry for that. And what I've done a pretty simple thing. That means the switch name and the IP address and assigned a location. So, and radius settings. That's it. So this is what you need. So make sure your uh, switch is available as NAD. That's the first step. And then let's go and understand the policy. Before we go to the actual policy, look at the authorization profile, and we will look at Meraki authorization profile. That is either wired map Meraki, or let me expand this a little. .1x employee wired Meraki. Let's expand this. And sorry about this. Some devices, this is kind of like a Chrome stickiness. This is nothing, it's coming from a previous screen. So we have created an authorization profile. Within that authorization profile, instead of dynamic ACL, Meraki support ACL or filter ID. So we are creating a wire.1x employee ACL and assigning a VLAN tag of 120. Please be mindful that unlike Catalyst, you cannot use named VLANs, hence we are using numbered VLAN here. And those are the two attributes we are sending in authorization profile. And let me quickly show you the policy associated with this authorization profile. We're going to go to our policy, authorization policy, and let me expand this, and let's find our Meraki wired host authorization profile. Here, as you can see, .1x employee wireless and wired Meraki. So this is for wireless. Let's find one for wired. Yes, this. As you can see, it says the user identity group is .1x employee. This is a local identity group, but you can use your AD. and I'm saying that this is a wired host, and the device location start with the location. Then this is our switch, right? It's matching to our switch, and then profile, we are attaching that profile, the profile which we just saw ACL and VLAN, and then we are assigning a tag called employee. So the ACL, if you want to look at the ACL, go to Work Center, TrustSec component, and come to Security Group ACL. Here you can see we have those ACLs available, and we have to create an equivalent of that within Meraki itself. And to do so, what you have to do, you have to go to network wide, group policies, and within group policies, you have to create that group policy matching exactly as the ACL or a filter ID, that is wire.1x employee. The name should match. You do not have to create any layer 3 firewall or layer 7 firewall. It just happened that the ACL name should be available in your group policy to come into enforcement. All right. So that's what we have done all this, and I have shown you the Meraki authorization policy as well. So now we are ready to connect our end host and verify how it gets authenticated and how it is getting the SGT. So let's look at quickly the MAC address. This is my window client, which is a .1x employee configured for .1x employee. Let me go back to ISE and get ready to see this host coming up and doing .1x authentication. Let me scroll back in here, and we are all right. Let me start the client authentication. This is the laptop which is connected to the switch. I'm going to switch it on, and you will see as it comes up, we'll have that MAC address coming up and authenticating within our network. Let's filter with that endpoint ID or the MAC address. Yes, this is authenticated. Let's see if it has got an IP address. Let's look at the authentication result first. As you can see, we are doing a map authentication, which is not right. Let me check if I'm looking at the right MAC address. E1, that is our .1x employee. Yes. And as you can see, .1x employee wired Meraki. This is the policy we are hitting, and all the IP address and other informations are available here. Okay, let me expand this authentication detail. As you can see, authentication success. We are doing .1x authentication. We are matching this authorization policy. Authorization result is profile, and then as you can see, we have the IP address. We have the security group of employee, and then we are getting, this is the NAD IP address, the switch, and then this is the radius attribute we are getting back. Finally, as you can see, we are parked in VLAN 120, and we are getting a tag of 4, employee 4, right? So this is getting authenticated as expected. Let me quickly check the IP address on the device. So we have got an IP address of 1053.120.4, 120.4, and based on that, this should be talking to our IoT host on port 3000, right? So let me go back and ping. As you can see, we can talk to the host based on port 3000. Let me see if I can show you something else. So we are going to log into the IoT host. And see if we can ping. As you can see, the host can access this IoT server on port 3000, but we cannot ping the host because only port 3000 is allowed. ICMP is not allowed. So let's cancel this out and let me show you the IP address of our PI. As you can see, we have this 80.180.5. All right. So this is how you can enforce policy. Before I let you go, let me show you this thing from Wireshark capture. As you can see, this is a Wireshark capture on a Dell laptop or the Windows laptop who is authenticated as employee. And if we filter from protocol, you can see we are doing the EAP authentication request response. So first you are doing a legacy request, which is being uh, declined, and then it switched to protected EAP, and finally EAP success. That means 822.1x authentication is successful. That is at packet 460. So if you go to packet 461 immediately after authentication, and you can see we'll have DHCP going on, and it is getting an IP address from switch as 120.4, and from here on the client can communicate however it is allowed for based on the policies and etc. So this is all I wanted to show you today, and I know there was like a lot of moving parts, and I hope you were able to follow. We were doing more like a show and tell. It's a different format than what we used to do. That means configuring things live, but that increases the video length. Hence I decided to do a show and tell. Let me know how you like this format, and if you have any feedback, comments, please do write in comment section. I'll do like, subscribe, share, and I'll see you in next video. Thank you very much.